We'll now discuss variation. The first type of variation we're going to look at is called direct variation. We say that y varies directly as x if y is equal to kx. K just needs to be a positive number and is known as our constant of proportionality. So it is a number that we will define for each individual problem, and it will stay constant for any problem of that type. So we'll do a few examples demonstrating this process. Here's our first problem. The distance you are from lightning varies directly with the time it takes to hear the thunder. If you are 2 miles away from the lightning, it takes 10 seconds. So we want to know what happens if you are 4 miles away. So essentially, this thing where it says varies directly tells me my distance, which I'm going to call d, is equal to k, which I don't know, that's my constant of proportionality. And this says it varies directly with the time it takes to hear the thunder. So I'll use t for time. We know that if we are 2 miles away, so d is 2, that t, the time it takes to hear, is 10 seconds. We can divide both sides by 10 to get that k is 1/5. So now I know k, and for this problem, it's not going to change. I now want to know what happens if I'm 4 miles away. So now I know d, and I'm trying to find t. Here I can multiply everything by 5 to get a 20 on the left and a t on the right. Therefore, if I'm 4 miles away, it should take 20 seconds. Our next example, the number of gallons of fuel used varies directly with the number of miles traveled. A 270-mile trip used 12 gallons, and we want to know what happens with a 400-mile trip. So it does say that it varies directly. I'm going to use G for gallons, K is our constant of proportionality, and the number of miles traveled, I'll use M for miles. Ultimately, it doesn't matter which letters you use as long as you know what they represent. We know that if M is 270, that we had 12 gallons. And now we can solve for K. Dividing by 270 gives us 0.044, which we rounded here, equal to K. Therefore, now I know what K is, and that's not going to change. I want to know what happens when I go 400 miles, so I'm going to substitute that in. And if we multiply this, 400 times 0.044, we get 17.6. And it's important to note that I did round my value of K here. If you don't round K or you use it to either more or less decimals than I did, your answer may be slightly different than mine, but that's just a result of rounding error. The distance a car needs to stop varies directly as the square of its speed. If we're going 70 kilometers per hour, it takes 120 meters to stop. So what happens if we're going at 80 kilometers per hour? So we know that our distance varies directly, so k times the square of its speed. So this time we have s squared. We know that if we're going 70 kilometers per hour, it takes 120 meters to stop. And it's important here that we actually move to the appropriate units. So 120 meters is 1.2 kilometers. We're not sure what k is, and then s is 70 squared. 70 squared will be 4,900, and then dividing 0.12 by this number gives us a very small number, 0.000024. we now have K, and we're going to let S be 80 this time. So we have times 80 squared. And if we try to multiply that out, we get approximately 0.16. So it takes approximately 160 meters to stop.